Hello, Keith Rucker here at VintageMachinery.org. Guys, so today we are back to work out here on this axle that actually started on a week or two ago. We actually cut a new one out of a piece of steel here, but we've got to cut some splines on this. I needed to order some cutters. They finally came in, so I got my cutters in stock now, and we are wanting today to get set up to cut the splines. Over at the horizontal milling machine, I've actually already got the dividing head set up over here from a job we just did last week or so, where we cut some gears, and we'll be doing very similar with cutting splines, very similar to cutting gears, where we have to index the part so many times in order to get that spline cut in there. Now, I am going to be doing a little bit different here. Normally with gear cutting, I use the actual horizontal arbor here with a wheel cutter to cut those gears, and you can cut splines the same way. You just have a wheel cutter that has an included angle on there. This one here, one of them has a 90-degree included angle, so 45-degree half angle, 90-degree total angle. The other side has a 60-degree included angle, which would be a 30-degree half angle, double angle. And I've got wheel cutters to do that. The problem that I'm running into with this particular job, though, is that both of the splines are cutting up against a shoulder, and the wheel cutters are a fairly large diameter. So you basically at the bottom, you got a large diameter coming out of that. Because I'm cutting up against a shoulder, I need a smaller diameter so that it will actually cut out quicker, and I don't have to cut up into that shoulder to actually get the spline to cut the full depth. Because of that, I'm going to actually, instead of using wheel cutters, I'm going to use a regular straight cutter. Let me show you. So these are the actual cutters I'm going to be using. Again, this one here has a 90-degree included angle on it. This one has a 60-degree included angle. But these are 3/4 inch diameter on their cutting arc, and that's going to allow that to come out of that bottom much faster. So when we're cutting up against that shoulder, we can get a lot closer to that shoulder than we have a larger diameter wheel cutter. Because of that, I'm going to have to do this kind of in a vertical mode rather than horizontal. Instead of putting my cutter on arbor, we're actually going to have to put the 90-degree head in here and do this like a vertical mill. So again, instead of doing it on the horizontal arbor here, we're going to put the vertical head on here, and we'll actually be cutting this cutter in this mode right here, where it's going to be running up and down, running on the side of it instead of on top. So a little bit different than how we normally cut gears. Now I know someone's going to ask, Keith, why are you doing this on the horizontal mill when you're really doing it vertical? Why not just do this over on the Wells Index vertical mill instead? And I could. The big reason why I want to do this on the horizontal mill is because this big dividing head that I've got, it fits this milling machine. This is the milling machine it's designed for. I could probably get it over there on my vertical mill, but this is a big, heavy dividing head. It's heavier than a typical dividing head. It'd be a lot of weight on that vertical mill. That mill over there is just not near as heavy built as this horizontal mill is. And yeah, this one here is just more rigid and larger. It's got a larger table on there. I just feel like going to be better off doing it here. And I do have a vertical head that we can move over here and use this for. So it's not a problem to do it on this mill machine. I do have to set the vertical head up, but could do it on the vertical mill. It'd be perfectly fine. But again, I just feel like that because this dividing head fits this machine, I'm better off using this machine. So we need to set this up in vertical mode. I need to take the horizontal arm off, get everything here, and move that head around. Let's go ahead and get it knocked out. I've done this before and gone into details on how to do it in previous videos. We'll kind of show you the process, but I'm not going to go into a lot of describing on what we're doing here. We'll just show us doing it real quick. we've got our vertical head mounted over here, and I think we're ready to go ahead and get this finished set up. Now, this head takes a NMTB 40 taper tool holder, and I got one over here for this size. These cutters are 3/8 inch shank, and that's what this is, a 3/8 inch end mill holder. And that's going to fit right up in there. Tighten my drawbar up. All right, got that tightened up. And get a Allen key Allen wrench for that. All right, that's indexed on the flat on there. And there we go. This head is designed where once you get it mounted in here, we can actually move it in and out using the adjuster on the top. So I'm going to uncouple this, the back bracket, which has to be 2 whenever you're moving it around. Let's see here. There we go. The overarm supports will come out, and you can move this to where you want it. Oh, I need to disconnect my top piece because it's going to limit me how far I can go. I won't slide forward until I get this bracket off the top here. It's catching it, so let me drop it down. There we go. Get that out of the way. Now I can bring it forward and it won't catch. All right. So we get that about where we want it. We can fine adjust that once we kind of get the part in there. Let's see, it needs to come back a little bit. That'll be close. We can adjust the table in and out from there. I'm going to go ahead and lock the overarm supports up here on the top. That arm, move it in and out. And again, so one thing about this head is it needs to be lubricated, and it is lubricated with oil, not grease. Even though you got these zerks on here, I've got a oil gun that goes into these zerks that look like a grease is fitting. And a lot of times people will put grease in these heads, and they are designed to run with oil. So you can see the oil coming out there. I'm going to go ahead and hit all of these oil fittings while I'm at it. All right, we're all lubricated. I've been starting to get this thing set up over here, and I realize I got a problem. The way this head is sticking out on this end of the mill, there's not enough clearance for the dividing head to come up underneath it to engage the cutter. And I really can't extend the cutter down any farther. With this being a universal head though, no problem. We can flip it around and actually turn it around so that this on this side, and that's what I'm going to do now, is get in here and just flip this thing around. So we're going to come in here and loosen up all these bolts right here. Ah, oh goodness. Came around quicker than I thought it would. And I'll get back over here and we'll tighten them back up. At least snug them up where I can get my angle set right. All right. Get this set on 90 degrees right here. There's a little scale that I can read this off of. Right there. And I'm all tightened down. Now we'll loosen up these bolts. And I'm just noticing I may have to turn this down up underneath the bottom to get it to flip around. Let's see what happens here. I don't think it's going to go all the way around. Right there. All right, we'll lock it back down again. All right, so that's the cool thing about this particular universal head is you can literally dial in just about any compound angle you want. 360 degrees in 2 axes to get whatever angle. So really flexible head for doing angle milling if needed. We're just doing 90 degrees here, but you know, you got a lot of flexibility with this universal head. All right, let me get this in here now. I think now the dividing head's not going to hit this, so we should be able to get it set up a little bit better. Guys, I decided to make a change in setup. After I kind of got things going over here, I realized pretty quickly with the cutter going straight up and down, and I was going to have to cut on this side because of the rotation of the cutter. I just didn't have enough room, enough clearance for the cutter to clear the front of the part before it ran into this my footstop. So there just wasn't enough clearance there. So yeah, I just made an adjustment here. We basically just got the cutter running now where it's working on top, more like in a horizontal position. You know, I guess somebody's gonna say, well, why am I worried with the universal head? I don't have a way to put a end mill holder in the 50 taper chuck over there and have it out far enough that it'll reach over to this. So using the universal head accomplishes that. I can use the cutters that I got. And like we talked about before, using a traditional wheel cutter on a horizontal arbor isn't going to be practical because I need that small radius so that I can clear the front here because of the sweep as it comes out. Anyway, we are going to get set up now. What I need to do is get this centered up onto the part. And just like I've always done doing this type of work, I'm just going to kind of eyeball it. So I'm going to bring my cutter kind of right over this, and then I'm just going to kind of eyeball it, get centered. That is close to center there. It's not exactly on center. I'm going to bring my table up now until it just barely cuts on there. All right, I'm just barely touching the top, and now what I'm going to do is I'm just going to sweep my cutter in and out, and what that does is it makes a mark right there on the top. And I'm going to actually lower that down just a little bit. I'm going to move the table over just a little bit. I'm going to do that again. I'm going to go in and out. I'm just trying to make a mark. What's going to happen is that cutter will touch the top, and it's made a very tiny mark right there. Let me zoom in and see if I can show you that. All right, if we look right here on the top, there's a wide mark there. That was the first one. Then a little in front of it right here is a real narrow mark. Now what that is telling me, that is the center of that shaft. That's the highest point on there. And now what I'm going to do is I'm just going to turn the cutter off. I'm going to just manually line that up on that little tiny mark, the center of my cutter, and it's close enough. I mean, where are we going to be within 1,000th when we do this? Our eye is extremely good at being able to do this. So I'm going to go ahead and just get it centered up. All right, I've got my cutter centered right here over that part. I also zeroed out the height on my scale so I can dial in the depth. I'll also note, I forgot to mention this, I've got a sample piece in here. This is basically just a piece that I turned the end down to match what I'm going to be cutting. I'm going to set up on this. I need to get my depth just right. There's some trial and error and getting a good fit on the part that you're making. So I'm going to do all that on the sample, and once I get everything set up right, we'll actually cut the spline on the actual axle. So if I mess this first one up, I can turn another one. We can just do this again. So anyway, just pointing that out as well. All right, let me come out. According to my measurements, and again, this is just gonna be a little bit of guesswork, and I'm gonna test it, but according to what I measured, the depth of cut needs to be 34 thousandths. We'll see if that's right. Once we fit it, we may have to fine tune things, but I'm just gonna dial in 34 thousandths on the depth. So I'm gonna bring the table up 34 thousandths right there. I will lock my table in place, and that should be my depth of cut. And with that, we're gonna cut this spline. This has got 21 divisions in it. I've got a 90-degree included angle, 45-degree single side, be a 90-degree on double angle. And anyway, let's cut a spline. All right, here goes nothing. I'm gonna let it feed in. I'm just gonna put a little cutting oil on that. I'm gonna come out. I think I need to go in just a touch farther than that and move my stop over just a little bit. All right. And we will make our first division here. Number 2. Alright, I can tell something ain't right. I don't think I may not be deep enough, may be the problem. Let me make a couple of measurements here. It just looks like it needs the top of the spline is a little bit wider than what it needs to be. Let me make a couple of quick measurements and see what I can come up with. So let me show you what I'm talking about. I'm looking at the top of that gap right there, and I measured that. It's about 80 thousandths wide, roughly. And measuring the other ones, the original one, it should be about 50 thousandths wide. So I've got it's about 30 thousandths wider than it should be, because this is a 45-degree angle on either side. For every thousandths that I feed down, it should close it up by that same amount. So because I'm going to be taking it off half off of one and half off the other, and I got 30 thousandths, I should be able to down feed an additional 15 thousandths and be about right where I need to be. I think I'm just going to kind of sneak up on this. I'm going to do 10 thousandths more, and we'll measure it again and kind of go from there. A lot of this is just trial and error until you get it right, and we'll probably be doing test fits at the end to get our final fit. So let me do 10 thousandths more. I'll probably just go ahead and cut all the splines, and we'll go from there. All right, here we go again. I went back to my first one. I'm gonna go ahead and feed in again, and it's taking just a little bit extra depth. Go to my next one here. All right, this is looking a lot more like the original. It's still about a thou or two larger, but I'm gonna just go with this and we'll fit the part on there. We may have to fuzz off just a little bit more, but I'd rather kind of sneak up on that than to just go too deep to start with. So let's go ahead and cut all our splines, and then we will check it out. I got the first two cut. I had gone back over to measure it, so I'm gonna go around to spline number 3, which should be this one right here. And we will continue on. All right, this should be the last spline. So we'll let this one finish cutting, and we'll clean it up and take it for a test fit and see how it looks. All right, coming out. All right, guys, I had to feed down just a little bit more and make another round on this, but this slides right up on there. I don't have any backlash in that gear, so I'm happy with that. I'm gonna call that right where it needs to be. Yeah, I like it. Okay, I'm gonna take this sample shaft out. We'll put in the real shaft and we'll cut it for real. Well, I've got the actual axle in now. We're ironed it for real, so to see how this goes, you go ahead and get all these teeth cut in here. Lines coming out of it. The test piece worked out just fine, so hopefully this one will too. I think that blew it off with the air hose. I'm going to go around it with a little emery cloth here just to make sure I don't have any burrs on those teeth. And I think we're ready to see if we can test it out here. Part that fits up on this and goes right on. No play in it. That's what I like to see. All right, that side is done. Well, guys, we are cutting our final spline, and I'll just mention before I did this, I did set it up on a sample piece like I did before. Pretty much the same process. This is a different spline, however, than what we were cutting before. So I did have to kind of reset everything up. Before we were cutting a 90-degree included angle. This one is a 60-degree included angle. So I had to change cutters and recenter it up. Of course, the diameter and the depth of cut is different. This one here, we're going 55 thousandths deep. We're cutting 30 splines. So I had to reset my plate over on the dividing head. We're using a 96-hole plate, and we're doing 16 holes per division. This being a 5-to-1 ratio dividing head. Basically, that's 1/6 of a turn, or 1/6 of a rotation every time. So 6 times 5 is 30. So that gives you 30 divisions. So we are doing this. Like I said, I had previously done my other one, did a test fit, everything worked out fine, so we're going back at the same settings we did before. So this should theoretically fit. Same process as before, letter cut, index your part, letter cut, index your part. We got to lock that down. We are using oil as we're cutting this, just to kind of get a little lubrication, help clear some of those little chips out. Again, using a little small diameter cutter so that it will have room to clear out the back. I got a stop set on my table so that we're not going past a certain point. We're stopping at the same place at every pass. And anyway, we're cruising along here. I'll continue on and bring you guys back here at the finish, and we'll do a test fit with the part. This should be the last pass. And we're going to check her out and see everything fits. All right, let's take her out. All right, let's clean this up. Get the chips off of it first. I'm gonna blow it with some air to get it good and clean. Okay, and then I'm gonna take a little bit of emery cloth, and I'm just gonna go around this just to make sure we don't have any burrs on the outside of that. All right, hit it with another blast of air just to make sure there's nothing in there. I'm gonna go get my part and we'll check it. This is the part that fits up on this end. And nice fit and no play in there. That is just what we need. All right, I think we got this job knocked out. I'm gonna pull this out and get her cleaned up good, and I think we'll be ready to go back to the customer. So just taking a quick look at these splines. This is the one with the 90-degree included angle. That's the first one that we did. And flip it over. And this is the one with the 60-degree angles, 30 tooth or 30 splines. This is the one we just finished cutting. And both of them fit just fine. So I'm happy with how that turned out. There's my sample that I did beforehand. Again, just doing that to make sure everything worked out like it should. I did a similar one here on a sample piece just to make sure everything would fit. So anyway, there we go. One spline job knocked out. One new axle ready to go back to the customer. Well, that was a fun little exercise, making that axle. It's the first time I've cut any splines in a really long time. I don't think I've ever done any on any of my YouTube videos, but yeah, it's pretty much like cutting a gear, very similar to cutting a gear, same basic principles. And yeah, you just use a different cutter, and of course it fits a little bit differently, but same principle. So with that, guys, that is a wrap. As always, thanks for watching. Please subscribe if you haven't already. Hit that like button, hit that thumbs up button. Yeah, leave some comments. If you haven't already, please subscribe to the channel. Big, huge thank you to those who support the site financially through Patreon, PayPal, etc. Really enables me to take the time to shoot these videos and bring them to you. And there's links for that down in the description below if you want to help out. And with that, I'm going to get out of here, give my customer a call, let him get out here and get this thing picked up, because I know he's anxious to get this back on his machine. It took me a while to get the cutters. I had to order the cutters, and yeah, one of them got hung up in shipping. It took almost 2 weeks to ship one cutter from North Carolina to Georgia. In the same time, I had something shipped all the way from California. It took 2 days. It just doesn't make any sense, but it is what it is. I finally got it. He's going to finally get his stuff back. Guys, with that, we're going to get out of here. We'll catch you guys on the next video. Again, as always, thanks for watching.